Okay, from now we discuss that throughput. So the throughput is the measure to how fast we can actually send data through the network. Actually, if you see that you may think that bandwidth and throughput is the same. So bandwidth means bit per second, and throughput, but throughput also the similar thing. But here is some difference between these two. Suppose a link may send bandwidth Bps, but we can send Tbps through this link, where T always less than B. Means bandwidth is a means potential measurement of the link, and throughput is the actual measurement of the link. Means bandwidth is the maximum capacity, and throughput is the आप कितना send कर रहे हो actual capacity of that link. So that is the thing. So in that, now there is some example of this throughput. So where a network with a bandwidth of 10 Mbps can pass only average of 1200 frames per minute, with each frame carrying over 10,000 bits. So now what is the throughput? Throughput equal to, so number of frames into per bit, total number of bits divided by 60 because it is almost 1/5 of this bandwidth. So 60, because there is a per minute, means 60 seconds, you can divide it seconds, so that's why bandwidth is 1/5 of. So you see that bandwidth and throughput is not similar. So go to the next. So next is latency or delay. Here, the latency or delay define how long to take for an entire message to complete arrive at the destination from the time first bit in the send out from the source. Source से कब का first bit निकला, then destination में कब पहुंचा. This is the time the entire message completely send arrive in the destination. Complete is arrive होने में कितना time लगा in between this. This is called latency. So latency is the 4 components: propagation time, transmission time, queuing time, and processing delay. These are four things. So if you see that latency is the propagation delay plus transmission delay, queuing time, and processing time. So where the first is the propagation time. Propagation time measure the time required to be traveled from one source to destination. Propagation time calculated by propagation time equal to distance by propagation speed. So as propagation speed is the speed which the bit is traveled through the medium from source to destination. So कितनी speed में जाता है, that is called the propagation speed. So we calculate propagation delay, the distance, total distance divided by propagation speed. It is fine propagation delay. Then transmission speed, the speed is which all bits in message arrive at the destination with different arrival time to the first and last bit. So what is the difference between last and first bit is called transmission time. The transmission time is message size by bandwidth. So where transmission time is the message size, total size of bandwidth of the BPS. So by that we can calculate. So here one of the problem. What is the propagation time? If the distance between the 2 points is 12,000 kilometer, aging speed is 2.4 1 ms in Kelvin. So you know that propagation time equal to 12,000 kilometer to 1,000 meter per second. So divided by propagation speed, directly it comes 5 ms. So millisecond. So the example show that a bit can go over the reduction in the 50 if directly equal between the source to destination. This is the one problem. Another problem is that we'll just go through it. What is the propagation time and transmission of 2 kb? And the email, if bandwidth is network 1 Gbps, assume that distance between the sender and receiver is 12,000 km and light travel at speed. So here we first calculate the transmission time. So first transmission time and propagation time. Propagation time is same thing 50 ms. And transmission time will be 1500 into 1 2.5 kbps. So it is 2500 into 8 divided by bandwidth is 10 to the 9. By that you can calculate. So here you can see that message is short and bandwidth is high. The denominator factor is the propagation time, not the transmission time. So transmission time can be ignored. It is small, that's why it is negligible. So this is another problem. So you just go through this. The same thing is there. So now, bandwidth and delay product. So this is called bandwidth and delay product. Now bandwidth and delay are the two performance matrices of the link. So you need both bandwidth also and delay product. So multiplication of these two, it performs the performance. It measures the performance of the link. However, what is the bare input of data conversion is that the product of these two. So now in that figure, this case one. So here bandwidth is 1 bps, delay is 5 seconds. So bandwidth delay product will be 5 bits. So how it sent like that? 1 second after delay is 1 bit. 2 second means 1 second, 1 second, 1 second, 1 second. Total 5 seconds is delay. So after 5 minutes. So next is sorry for interruption. So next bit is in the case second. So here also is see 4 bps, delay 5. So bandwidth delay is 20 bits. So it is here 20 total 20 bits. So this bandwidth delay product define the number of bits that can be filled the link. So we can say that if it is on a pipe, the cross section is the bandwidth and length will be the delay. So total performance will be the size of this pipe will be bandwidth into delay. So up to this, the third chapter complete. So I think you should we should conclude here.